Good morning and welcome to Space News Day 14. My name's Mike. I read the news so you don't have to. Let's get into an Ars Technica or space news or payload article. I'm not sure what we're going to read today. We only have one article. This is from Theo Nicitopoulos on why interstellar objects like Oumuamua and Borisov may hold clues to exoplanets. This is on Ars Technica, the place where we usually read articles from. I'm not sure what's happening with Eric Berger and Stefan Clark. They've been posting almost daily for a couple of weeks now, and it seems maybe they've taken a vacation. Let's have a look at this. Two celestial interlopers in solar system have scientists eagerly anticipating more. So, what is Oumuamua and what is Borisov? In the photo here, we see the first interstellar interloper detected passing through the solar system. One Oumuamua came within 24 million miles of the sun in 2014. It's difficult to know exactly what Oumuamua looked like, but it was probably odd-shaped and elongated as depicted in the illustration. Okay, so to me this looks like a comet. It's not on the, it does not look like it's on the scale of a planet or a star. So what is a interstellar interloper? Let's ask Copilot. See, if it just looks up interloper, it's going to give us the wrong answer. Also, I find that this is, okay, reasonably fast, yeah. Someone who intrudes or interferes in the affairs of others without being invited. Okay, so how is this intruding or interfering in the solar system's affairs? And also, I realized yesterday that I tend to look to my other monitor where I have my presentation, like my OBS Studio, what I look like, what you're seeing on my right. So I'm going to try and spend more time focusing on the camera. I do apologize. I don't want to take away any time from your beautiful face. So an interstellar interloper is a fascinating term that refers to an object that ventures into our solar system from the vast expanse. The celestial wanderers are like cosmic nomads, journeying across. So Oumuamua came into our solar system. It didn't behave like a typical comet, and its unusual characteristics defied easy categorization. So I'm surprised that that we're able to track what I assume are quite small objects entering what is so large as our own solar system. How do we track those? Why do we care about something entering our solar system? I guess between our solar system and other solar systems, there's just such a vast expanse of nothingness, nothingness that we don't expect things to cross paths very often with our solar system. I mean, that sounds unlikely, especially for objects as kind of common or routine as small rocks in space. So it was the James Webb that allowed us to investigate the chemical composition, origin, and conditions in their home systems. Okay. So Oumuamua was, it didn't behave like a typical comet. So it's unclear what to classify this beyond an interstellar interloper. And then there's Borisov, which was a wandering comet, exhibiting more familiar traits. It provided valuable clues about planetary building blocks forged in an alien star system. That's a really cool way to put that. These are rocks that have come from alien solar systems, let's say. Okay, we'll continue with the article. So Oumuamua is a Hawaiian word that roughly translates to messenger from afar arriving first. That's just lovely. Borisov discovered the only other known interstellar interloper using a self-built telescope at the Margot Observatory in Crimea. While typical asteroids and comets in the solar system orbit the sun, Oumuamua and Borisov are celestial nomads. So how do we know this? Please explain how we know that they're interlopers. So within the orbit of Neptune alone, there could be around 10,000 Oumuamua-sized interstellar objects. Yeah, these must be more common than we think, or it must be more common than just the two that we've identified so far. Our researchers are busy trying to answer basic questions about these objects, including where they came from and how they end up wandering the galaxy. So in this photo here, Borisov appears as a fuzzy blue dot in front of a distant spiral galaxy. Okay, so if we take a picture of the night sky, it shocks me that this this comet would be much brighter than many other things in this area of the sky. Obviously, when you point your camera in one area in space, you can see tens of thousands of galaxies. So this must be a very zoomed in picture. So this was taken by Hubble when the object was approximately 200 million miles from Earth. Miles to light years. Okay, so it's on 10 to the minus 5 light years. Okay, let's just, hopefully they'll tell us how we actually identify, what do we call them again? Interstellar interlopers. It's quite a mouthful. So scientists, beginning at the beginning of the 18th century, astronomers considered the possibility that interstellar objects exist, and lately computer models have shown that the solar system sent its own population of smaller bodies. I mean, we are aliens to other planets, obviously, into the voids of interstellar space long ago due to gravitational interactions with giant planets. Scientists have expected most interlopers to be exocomets composed of icy materials. Borisov fits this profile. It has a tail made of gases and dust created by ices that evaporated during its close passage to the sun. A tail made of gases. Okay, so those gases must be gravitationally attracted to this interloper in order for those gases to continue to trail. I know there's no, obviously with the absence of atmospheric drag, the gases could likely stay close to the object that they first emanated from, but over time, any impact from even things as simple as solar force, so solar winds, will push gas away from things like this interloping object. So I'm surprised that this just kind of large tail of gas is there. Maybe it's like a jet stream, maybe slowly over time. No, that doesn't make sense. So this suggests that it is originated in the outer region of a planetary system where temperatures were cold enough for gases like carbon monoxide to have frozen onto its rocks. One potential culprit is a stellar flyby. So this is when the gravity of a passing star can eject smaller bodies. If any of you have played Kerbal Space Program, you will know that planets have spheres of influence, and you will have visualized in Kerbal Space Program that sphere of influence. Their mathematics aren't exactly correct. At any point in time, we are influenced by these spheres of influence of all of these other planets, of everything else in the solar system. and beyond in the universe. Um, and in Kerbal, you are only impacted by a single sphere of influence at any given time. And this is to simplify the math required and the physics calculations, and so that your game doesn't explode. A giant planet could also eject an object from the outer regions of a planetary system if an asteroid or comet gets close enough for a planet's gravitational tug to speed up the smaller body enough for it to escape its star's hold. So a planet comes by, gives the interstellar object, this interloper, enough acceleration to escape its current sphere of influence, let's say, and become a wanderer between solar systems, eventually to become to fall into another system sphere of influence and thus start orbiting that planet. So I'm going to look for how they know that this is an interloper. So commonality currently between these two interlopers is that they have outgassing, they have ice and gaseous tails. Here you go, searching for nomads. If Pan-STARRS didn't observe where we did that particular night, it's likely that Oumuamua would never have been found. So an observatory's telescope images an entire region of the sky every few nights, and its primary mirror has... So effectively, if you image the same region every night, you should be able to detect objects coming into that region over time, and then given certain properties, distance and movement of those objects over time, you should be able to calculate simple terms like the velocity of the rock, the acceleration of the object, and that will tell you, and then you can trace out rough orbital trajectories to understand, oh, this device clearly could not have come from our planet. It's traveling too fast in one direction to have been to have come from, let's say, the other side of the solar system. Well, this is a new word. Planetesimals are the building blocks of exoplanets. Okay, that's a pretty cute word. Planetesimals. So the eventual kind of so the eventual outcome for these interstellar interlopers, they could spend an eternity wandering the vast voids of space, hopping from solar system to solar system, just traveling the universe with no goal in mind. Or maybe they get captured by the influence of a star, or perhaps they collapse into a disk of evolving gas and dust in a new planetary system and begin their journeys all over again. Astronomers estimate there could be more interstellar objects in the Milky Way than stars in the observable universe. Okay. Nice article. Not very technical. It's still fun. I will show you this image again. Oh yeah, this is the 10-year legacy survey of space and time. So pick a point in space, survey that for 10 years. It will deliver a 500 petabyte set of images and data products that will address some of the most pressing questions. Holy cow. Where is this being hosted? Like what? The backups for things like this must be enormous. Okay, I'm sure they will have to have worked on some custom compression algorithms to optimize the size of the backup images for all of these data products. So the LSST is designed to address four science areas: probing dark energy, dark matter, taking an inventory of the solar system, exploring, dang it, the transient optical sky, and mapping the Milky Way. Yeah, they process and store more than 20 terabytes of data every night. All right. So we've actually burnt out all of our Ars Technica articles, Ars Technica, the articles. You can see we've read most of them. There are a few daily telescopes that we haven't looked up. Let's see if there's anything else on space news or payload that we'd like to cover. So Virgin Galactic investigating dropped pin on most recent suborbital flight. Okay. As in a passenger dropped a pin. Well, there's a SPAC merger deal. So for those of you in the know, SPACs have not been doing well. A lot of the companies that went public via SPAC 3-4 years ago are having financial difficulty. They did not, their initial IPOs showed promise. They made a lot of money from the public and then spent it all and did not have the expected revenue outcomes to merit higher stock valuations, and so they eventually, I think a lot of them just are on their way to becoming delisted from the New York Stock Exchange. So let's have a look at this. So Lynx Global is a cell tower and space kind of company. So it raised money for the direct to smartphone operator and listed shares on NASDAQ. So these cell phone companies are building cell phone towers in space, and they're coming for whoever is designing and building land towers. There will always be a need to have land towers. I'm sure they have better throughput, and they solve certain needs for cell phone operation. But if I can communicate with a cell phone tower in space from anywhere in the world, that sounds like a better deal than communicating with than needing to buy up land to put up cell phone towers that emanate 5G and obviously cause me cancer. And I'm kidding. I'm kidding. Okay, so what does this cell phone tower look like? Well, small satellite hardware, a cellular mobile stack, that's COTS, commercial off the shelf, virtual cell network in the sky, the Doppler shift compensation unit, timing compensation, and patented IP. They have 73 patents or pending, granted or pending across 11 patent families. Wow. They leverage network on the edge architecture where phones connect with Lynx satellites just as a terrestrial tower. It'd be really cool to learn more and understand more about how cell phone towers work. I can make guesses as to what the cellular mobile stack would look like, and we could even find this online, like GitHub, cell phone stack. So here is a cell scanner by Zhao Xianzhen, I think. So it looks like this was based off of someone else's LTE cell scanner, Everitania. Okay, so you can call a cell search binary with a certain frequency, and it will tell you if it detected a cell. Wow. I mean, if we have a look at this image, this looks like a reception grid. So at this is a band. We see that there's more. There's a bunch of data being transmitted. I would assume that if I ran this, had the right antenna set up in my house, and then had my phone nearby, we would see very large bands in whatever frequency my phone is transmitting at. Could we learn more about what this was what the place this was forked from? Let's do that. Come on. So it's a collection of tools to locate and track LTE base station cells using very low performance RF front ends. Here's a dongle. So this RTL2832 is an integrated circuit produced to demodulate digital TV signals and send them to a host computer over the USB bus. Okay, so you can pick up digital TV and you can watch it via just a USB dongle. It's kind of fun. And these are all, this is all run by software-defined radio technology, which is not surprising. So I'm curious, what does this kind of code look like? So we have a searcher thread, producer thread, constants, LT tracker, cell search. Okay, what does cell search do? I'm not sure what this is. Not sure what this is, but everything else is pretty routine. We have the usage function, command line, da 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 da. Okay, that's just the command line. LT tracker. Does not tell you what it does. Again, another one of these are all command line interface. It looks like you put all of his logic within the command line interface. Here we go, config USB. So it's looking for an RTL SDR. So I don't know what RTL is. I know SDR is software defined radio here. What does RTL stand for? Killing me. Real Tech Software. Okay. Tis the brand. All right. We're going to quickly finish this up. I'm kind of going off on a bit of a tangent here, but I'm very interested. Set of sampling frequency. Okay, so where's this coming from? Let's just go. Oh. Yeah, but search for the symbol. Find it in the header. God, you annoy me. So like the reason I'm not opening some of these files like capbuff is because I'm not sure what capbuff stands for. It's not in the, they usually, if you have, if you're writing software and you have terms that are abbreviations or acronyms, it's nice to be very transparent with what those are abbreviating, what those acronyms do stand for in your header. So this is a bit annoying, but that's okay. Let's keep going. So we have a callback package here, which includes whatever this Realtek SDR type is, as well as a buffer. So it looks like this is for capturing samples. I mean, where are we right now? We are on the inside of this cap buff. So capture buffer, that's what that means, of Realtek SDR callback. Okay, so this is when the Realtek SDR has a buffer. This is the callback that's called. It gets past the buffer, the length of the buffer, and then context. This is very popular in a lot of C libraries, is you just pass a void pointer to some context, and then you can define the context within the callback itself. Now, let's see what the context is used for. Callback package type, which is the buffer and device the real-time software-defined radio device type. Okay. So let's see what dev is doing here. Come on. There you go. So in this file, dev was used to, so if you, this is access to the device. So if you want to, for example, cancel some transfer, it looks like you could do that. What's this? You can set the center frequency. So this dev object is letting you communicate with it is the kind of digital representation of the device. It's of this real-time logic software-defined radio. Okay, so get tuner type, see and check that it's the actual center frequency that it was programmed around. Do some calculations, reset the buffer, Okay, it's kind of cool. Let's get out of here. So what did we learn? Cellular mobile stack, that's what we were just talking about. That's what that would, roughly what that would look like, although that was how we would communicate with a device that on board that device already has a cellular and mobile stack, or at least a software-defined radio, which would be included in this. So Link Global has agreed to a merger for the direct-to-smartphone operator. The deal was with Slamcore, which is a company led by Alex Rodriguez. That's kind of funny. Just a random famous guy, former MLB player, former MLB super slugger, throwing money around. So this values Link at $800 million, with 3 satellites in orbit providing intermittent connectivity to a handful of remote locations. It sought the merger to fund a LEO constellation seeking to extend the reach of terrestrial mobile network operators beyond their cell towers. They are not the only ones trying to do this. I believe they're going to be up against Starlink and probably Kuiper, which won't be easy. So the SPAC has less than $99 million in trust following investor redemption since raising $575 million from its stock debut. Again, these SPACs have really gone downhill in terms of their funding, the amount of funding and money that's available to the company within. So SLAM investors will be allowed to recoup their investments from the trust before the merger closes instead of taking a stake in the combined company. So it's pursuing a number of avenues to raise capital. They anticipate that some of these avenues will provide capital to Link prior to closing of the merger with SLAM. Here are the business projections, and then I'm going to leave you there. So the EBITDA. So number of satellites in orbit grows from the current first quarter 24 to fourth quarter 25. They want to send up over 70 satellites. If they don't have those already planned, I don't know how they've envisioned booking all of the launch vehicles, the spaces on launch vehicles required to get all the satellites up. Although perhaps these satellites are so small, like 1U, 2U CubeSats, I doubt it, but perhaps that they're able to book just a few launches and pack vehicles into a few slots in order to get this quantity up in time. That's quite a rush. So Link is okay. So satellites in orbit 3 to 74 by the fourth quarter next year. Number of subscribers, some MNO subscribers, it gets up to 107. Not sure what that means. Revenue, I assume this is 41.3 million, and so therefore I assume the subscriber count are paying customers. And I wonder how this works in the world of, cell phone towers, whether they be terrestrial or whether they be orbiting the Earth. I assume whatever cell phone company wants to pay to use that infrastructure charges, obviously forwards that cost onto their clients. But my question is, so what are the subscribers here? Is that the number of phones that the number of subscribers that cell phone provider says that they will be that they have kind of on their network and that they will be connecting through this through their infrastructure? I assume so. So the expenses, they're able to spend, they burn about 4 million a quarter, pushing that up to 5 million by the end of 24 or 25, sorry. Their capital expenditures go down all the way to 46. They're $46 million in the red with EBITDA. Let's get that again. Earnings before interest, taxes, depreciation, and amortization of $32.3 million. So that's take their revenue. That's before, so interest, taxes, depreciation, and amortization. So what about earnings? So is this impacted by their costs? So if they have $32 million in earnings in one quarter, they have a certain amount of cash flow that's going to be, about 20 million, $25 million in the red. It's a bit odd that it's funny that in this second quarter of 25, they're able to achieve a positive cash flow. I wonder why. Oh yeah, you look at that. The cumulative cash flow net goes well into the red. So cash flow wise, it's minus 150. It's negative 155. Capital expenditures negative 46. So they're going to be in the hole about 250 million. All things said and done to get 74 satellites into space. Ending cash balance. So beginning cash balance, they currently have 10.1 and they expect to have 75.7. Therefore, their ending cash balance is 62.1 with a head count of 191 full-time employees. Some of these numbers don't make a ton of sense to me. So if their capital expenditures are down 46 million, I guess that's total over time, right? No. So here they have 11.9, and then here in the next quarter they lose another 8 million. Or their EBITDA is negative 8 million. So where does this number come from? Because shouldn't that be 11.9? Mike, I'm bringing out the calculator. You can't see it, but 7.4 minus 11.9 gives us, negative, so 7.4 plus 11.9 gives us 19.3. I don't see that number here. All right, we're getting into the financing and accounting of things, which I'm clearly not very good at. Anyways, thank you for sticking around. This has been Space News. We talked about interstellar interlopers via that Ars Technica article. We also talked a little bit about Link Global and then dove into a rabbit hole regarding cellular network technology, what a software-defined radio GitHub repository looks like with that stack, how you would build up a stack like so. I want to, again, thank you for sticking around, and we will talk soon. Have a great day. Bye-bye.